Hello there everyone, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vendibona, and from this episode we are going to try out some database designing questions. In this first exercise, we are going to go through this scenario and find out the entities and their attributes and their relationships and their keys. If you like, you can pause this video and read this scenario very carefully. Also, if you like, you can identify each of them when you read through the scenario. Let's see what it says in the first exercise. A company database needs to store information about employees identified by social security number with salary and phone as attributes, departments identified by department numbers with department name and budget as attributes, and children of employees with name and age as attributes. So here it directly says what are the entities and their attributes. So we can identify entities as employees, departments, and children of the employees. Under the employees, there are three attributes: social security number, salary, and the phone. Under the departments entity, there are three attributes: department number, department name, and the budget. And for the children of employees entity, it has two attributes: name and age. And with this description, we can identify the relationships between the entities. It says employees work in departments. When department is removed, employee data should remain. Each department is managed by an employee. When manager leaves company, department data should remain. A child must be identified uniquely by an autonumber. Assume that only one parent works for the company. We are not interested in information about a child once the parent leaves the company. From the first fact, we can clearly identify there are two distinctive entities, employee and the department. You could not keep the department information in the employees because when department is removed, the employee data should be remained. Therefore, these information should be kept in two different tables. From the second fact, we have to find a way to store the manager information of each department. From the third and fourth facts, we have to identify what is the relationship between the child and the parent. And now we have gone through the scenario description. So let's identify what are the initial entities. As I said earlier, the initial entities are the employee, the department, and the child. They are directly mentioning in the description. And now for the attributes. In employee entity, we can identify the social security number, the salary, and the phone. And for the department, the attributes are the department number, the department name, and the budget. And for the child, we can identify a ID, a name, and the age. In here, the ID attribute of the child entity is not directly mentioned in the description, but it says a child must be identified uniquely by an autonumber. So we have included this ID attribute as the autonumber to uniquely identify each record. And for the relationships, we can clearly identify there is a one-to-many relationship between the employee entity and the child entity. A one employee may have one child or many children, and a one child has only exactly a one employee parent, because there is a statement saying, assume that only one parent works for the company. And also there is another statement saying, we are not interested in information about a child once the parent leaves the company. That means, once the employee record is deleted from the employee entity, the related child records should be deleted. That means we have to enforce the cascade delete referential integrity in this relationship. And now what is the relationship between the employee and the department entities? In here we have to mention two things. there are many employees who works for each department, and there is exactly one employee who manages each department. With regarding to that, it says when department is removed, employee data should remain, and also when manager leaves the company, department data should remain. So the ideal way is to use two different entities for the work related records and the managing related records. So for this manage entity, it has a one-to-one relationship between the department entity and also with the employee entity. And among the department entity and the works entity, it has a one-to-many relationship. And among the works entity and the employee entity, it has also a one-to-many relationship. Since each department can have at most one manager, each department number can appear at most once in the managers table, making it a key for the managers. Now I'll ask an extra question. What would you do if you need a department to have more than one manager? Yes, you have to make a composite key by including the department number as well as the social security number for the manage table. And with this final design, when a department record is deleted, only the related records in the manage table and the works table will be deleted, and the employee data will be kept remain. And also, whenever an employee record is deleted, only the related records in the manage table and the works table will be deleted, and the department data will be kept remain. So in this way, there are no empty fields in both the employee table and the department table. For the final design, the entities, the attributes and the keys are like this. For the employee table, social security number would be the primary key. For the department table, the department number would be the primary key. For the child table, the ID would be the primary key, and we are using social security number as the foreign key. And for the new table, work table, the social security number and the department number are foreign keys, and by combining them we are creating a composite primary key. And for the manage table, the department number and the social security number would be the foreign keys, and we are using the department number as the primary key. Well done! You completed the exercise 1, and here comes the exercise 2. We recommend you to pause this video and read this carefully and try it by yourself. So now let's analyze what it says. Although you always wanted to be an artist, you ended up being an expert on databases. Your old love is still there, however, so you set up a database company, Artbase, that builds a product for art galleries. The core of this product is a database with a schema that captures all the information that galleries need to maintain. Now, according to what it says, you have to be familiar with art gallery jargon. Galleries keep information about artists, their names, birthplaces, age and style of art. So here comes a one entity, artist, and attributes are the name, birthplace, age and style of art. For each piece of artwork, the artist, the year it was made, the title, its type of art as painting, lithograph, sculptures, photographs, and its price must be stored. So here comes another entity, the artwork. Assume that each piece of artwork was created by exactly one artist. So this statement might help you to create the relationship between the artwork and the artist. Pieces of artwork are also classified into groups of various kinds. For example, portraits, still life, works by Picasso or works of the 19th century. A given piece may belong to more than one group. Each group is identified by a name, like those just given, that describes the group. In here, we can identify a major entity called group. In one group, there may be many artworks, and one artwork may belong to many groups. Therefore, among the artwork and the group, there is a many-to-many relationship. We need to avoid the many-to-many relationship by including a junction table. We can call this junction table as classification. Finally, galleries keep information about customers. So here comes another entity, customers. For each customer, galleries want to know the person's name, address, total amount of dollars spent in the gallery. It is very important. And the artists and groups of art that the customer tends to like. So, according to the last part, we have to track customers' purchases. Therefore, we have to maintain another entity called purchase. Good. As we now had thoroughly gone through the scenario, we can now decide the initial entities and their attributes. There are 6 entities: the customer, purchase, classification, group, artist, and artwork. If we look at the attributes, customer has the name and address, the purchase entity has the customer and the artwork, the classification table has the artwork and the group, and the group has the name, the artist has the name, birthplace, age, and the style of art, and the artwork has artist, year, title, type of art, and the price. And here is our final design. Among the artist and the artwork, there is a one-to-many relationship because one artist may have created one or more artworks, but one artwork was only created by exactly one artist. And among the artwork and the group, as I said earlier, there is a many-to-many relationship. So to avoid that, we are using a junction table called as the classification. And then we are specifically using a purchase table to track each of the customer's purchases, because that is very important as the description said. And using that, we can query what group of artworks is customer mostly purchased in. And with that information, we can conclude what are the customer's likenesses. And now the final thing, identify the keys of the finalized entities. So for the customer entity, the customer ID is the primary key. For the artist entity, the artist ID is the primary key. And here in the artwork, the artist ID comes as the foreign key, and we are using the primary key as the artwork ID. And for the purchase entity, the customer ID and the artwork ID comes as foreign keys, and we are using both of them as the composite primary key. And for the classification entity, the foreign keys are artwork ID and the group ID, and also we are using both of them as the composite primary key. And for the group table, the group ID is the primary key. Yes, we have completed the second exercise. Hope your answers are correct as these. And now for the third exercise, imagine your local computer shop wishes to record its sales in a database. So here is a handwritten list of sales produced by the salesman. What you need to do is identify the mistakes in here and correct it. So what kind of mistakes can you identify in here? Yes, there is a heavy data duplication. If you check the order number and the date, there are duplicated records. The order number 001 with the date 12/7/2008, it is repeated 3 times. And if you check the stock ID and the description and the price, it has also duplicated records. The stock ID of the keyboard with its price is repeated 2 times, and also for the mouse. Data duplication is not good. Therefore, we have to keep this information in separate tables. The order number and the date should be in a one table. The stock ID, description and the price should be in a one table, and the mapping between these two tables with the quantity should be in a one table. And this should be our final design. In the order table, the order number is the primary key. In the stock table, the stock ID is the primary key, and the mapping between these two tables is called as the order details. In the order details table, we are using the order number and the stock ID as the foreign keys, and using both of them, we are making a composite primary key. And also, this order details table includes the quantity attribute. And here is how it sees with the data. You can see there is no data duplication. In the order table, it listed down all of the orders with the order number and the date the order took place. In the stock table, it listed down all of the products. In the order details table, it mentions in what quantity the products were ordered in the orders. Yes, we completed the third exercise. Now let's move into the final one. Answer each of the following questions briefly. The questions are based on the following relational schema. So we have three entities in here: the employee, works, and the department. In the employee table, the employee ID, the employee name, the age, and the salary is given as the attributes. And for the works table, employee ID, department ID, work time is given as the attributes. In the department table, the department ID, the department name, the budget, and the manager ID is given as the attributes. Now the first question: what entity have the relationship with the department, and what is the type of the relationship? It's a simple question. The answer is the works entity, and the works entity have a one-to-many relationship with the department entity. And the second question, here is a tough one. What could happen when a user attempts to delete a record from the department? Remember referential integrity, the cascade delete? Majorly two things could be happen depending on how you enforce the referential integrity. In one occasion, it will delete all the work records that refers it, or else it will not allow the deletion of the department record if some works record refers to it. These two answers are just enough for this question, but remember, a lot of things could make happen. For example, if you are an expert in database administration, knows the structured query language, you can make for every work record that refers to it, set the department ID field to the department of some existing default department. Or else you can make for every work record that refers to it, set the department ID field to null. Wonderful! We have completed 4 exercises under this episode, summing up all of the fundamentals that we have learned in the 5th section, database packages. We spent a lot of time for this area because database designing is a vital part if you are moving into software, IT and computer science field. So with this episode, we are going to wind up the 5th section, database packages, and start the next lecture with the 6th section, elementary concept of objects and classes. If you are looking for more advanced concepts in databases, check our YouTube channel for more courses. So thank you for watching and see you in the next lecture. This video brought to you by edupediaworld.com. Watch more from our website.